So this video is about converting velocity graphs to position graphs. So taking the information you get about speed and direction of an object and turning it into where might that object be in space. So first off, a couple quick reminders. What does velocity mean? Well, it's the rate of change in position. So how quickly you are changing your position, or the object is changing its position during its motion, and in which direction it's going. So you can learn three things from that. First one being how far it goes, second one being which way it goes, and the third one being how fast it gets there. So those will kind of be the three things that we'll take advantage of to determine, plot out where an object is based on its motion in the velocity realm. So steps to convert. So here's our graph right here where we see we have a velocity line. First step is we want to find the area between the velocity line and the time axis. That area is going to give us our displacement. So if we take a look here, we have a triangle there, we have a triangle here, and we have a rectangle over here. So now I want to try and find the area of these objects. Well, for the first triangle, we have a base of 2 times a height of 2, and we're going to cut that in half based on our area of a triangle. So we're going to have a displacement of plus 2 meters. We'll call this part A right here. And let's put that A in front. For part B, which will be down here, we have a width of 2. We have a height of -2, and we have to divide by 2 because it's the area of a triangle again. So we have a displacement of -2 meters. For the last part, part C, our rectangle, we're going 2 meters per second for 1 second. So that means we're going to have displacement there of plus 2 meters. So what did this object do? Well, it went out 2 meters, it went back 2 meters, and then it's going to go back out 2 meters again from where in the last part of the motion. So our next step is going to be to plot this out. So again, our displacements were plus 2 for the first 2 seconds, minus 2 for the next 2 seconds, and plus 2 meters for the last second. So we really don't know where this starts, but we need to pick a spot that will allow it to fit on the graph. Pretty lenient here. We got a little bit of room to work with here, but I'm going to pick out 0 as my starting spot. So I'm going to put a dot there at 0. And then I'm going to put in my displacements for each location. So we started at 0. Now we're going to be at plus 2 meters after 2 seconds. And then we'll go back 2 meters over the next 2 seconds based on the displacements and areas we found. And then we're going to go back out 2 meters again in that final second. So we have these 4 locations. This tells me where I'm going to be at each point in time based on the displacements I found in the previous graph. So look back at our velocity graph to figure out how we're going to connect those points based on the shape of this graph. So remember, velocity tells you the slope of the position versus time graph. Because velocity is rate and change, and that's what slope is. Well, for instance, in part A here, our slope starts out at 2 and ends at 0. So that means my slope is going to go from plus 2 to 0, meaning that's going to get flatter as we go along. A curve that gets flat as we go along, so for A, is going to have a shape kind of like this, with a steeper slope initially down here and a flatter slope up here at the top. For part B, my slope starts at 0 and ends down here at -2. So now my slope is going from 0 to -2. So if it were to draw a line, that curve that emulates that, we're going to start out flat and then get steeper as we go along. Sort of like that. In the end, for the last second, our slope the entire time is plus 2. So for C, we have a constant slope of plus 2, which is going to look something like this. So now we have to try and plot this out on our velocity graph. So we go back here, we have our locations at 2, back here at 0, and up here at 2. And we said we had a curve going flattening out, zoom along for the first part, we had a curve that was getting steeper for the second part, and then we had a straight line like that for the last portion. So that's going to tell me how I'm going to connect. Again, the slopes are going to tell me how I'm going to connect those points based on whether they're moving towards 0 or away from 0. And that tells you, again, 0 is where you're going to have that flat horizontal slope up here, and then any other value, be it positive or negative, will be something steeper than that. Based on the sign will tell you the direction. So hopefully that makes sense and helps clear up some ideas and gives you a good start for the homework.